So in this lecture, we are going to discuss about flow control and error control in TCP. Okay. So first of all, let us discuss about flow control. So TCP, that is the transmission control protocol, uses sliding window to handle the flow control. Okay. So the TCP protocol is going to use the sliding window concept to deal with the flow control mechanism. So actually this sliding window protocol which the TCP is using, it uses a combination of go back and protocol and selective repeat sliding window protocol. Okay, so while we were discussing about flow control in the data link layer, we discussed about go back and protocol, and then we discussed about selective repeat sliding window protocol, isn't it? So uh, TCP is going to use a combination, or it is going to choose between these two, that is go back and selective repeat sliding window protocol. Okay, so we shall see why it is going to use these protocols between. I mean, why it is going to use both the concepts of go back and protocol and selective repeat protocol means we'll just see. Okay, so the sliding window protocol is going to look like the go back and protocol. Okay, the first thing, the sliding window protocol in TCP is going to look like go back and protocol because it is not going to use any negative acknowledgements. Okay, so the TCP protocol is not going to use any negative acknowledgements. So in go back and also we do not have any negative acknowledgements. So for this reason, we can consider this TCP sliding window as somewhat similar to go back and protocol. So one point you have to remember is that I'm sorry. So it is not going to use the negative acknowledgement. And the second thing is the TCP flow control is going to use a sliding window, which is somewhat similar to selective repeat. So the sliding window looks like selective repeat because the receiver is going to hold the out of order segments until the missing segment is going to arrive. So what happens in selective repeat? If you remember in the data link layer in the selective repeat, what happens? Let us say this is sender and this is receiver. Sender is going to send 1, 2, 3, and now let us say the receiver has received 1 and 3. So if you use selective repeat means what actually happens? Okay, now the receiver waits until the second frame with respect to data link layer I'm talking. So the receiver will wait until and unless this second frame also comes. Only when the second frame comes, then all these three frames are grouped together and it is delivered to the receiver. So in the same way, in TCP also, it is going to use this selective repeat. That is, it is going to the receiver is going to hold these out of order segments. That is, let us say the receiver got 1, 3 and 4. Okay, now what it is going to, it is not going to process all this. First of all, it is going to hold all these out of order segments, okay, until the missing one, let us say the second segment arrives. Okay, so in TCP we are going to talk about these data chunks as segments. So the receiver is going to wait until the second segment arrives. Only when the second segment arrives, then only it is completely then only it completely processes the complete information. So in this manner we can say the flow control, I mean, or the sliding window in TCP is going to look like both go back and protocol and the selective repeat protocol. Okay, someone has switched on their microphone. I hope, can you please turn off the microphone? Okay, so now coming to the difference between the sliding window protocol which we have used in data link layer and transport layer. నానా ఎవరో మీ మైక్రోఫోన్ ఆన్ చేసి వదిలేశారు, అది డిస్టర్బెన్స్ వస్తుంది. కెన్ యూ ప్లీజ్ స్విచ్ ఆఫ్ దట్ మైక్రోఫోన్, సమ్వన్? యా, ఓకే, థ్యాంక్ యూ. Now, so actually the sliding window which we are using in the data link layer is different from the sliding window which we are using in transport layer. Okay, we have major two big differences. Okay, so first difference is the sliding window of the TCP which we are using at the transport layer is byte oriented, but when we discuss about the sliding window at the data link layer, it is which oriented? Frame oriented. Okay, so sliding window at the data link layer is frame oriented, whereas sliding window at the transport layer is byte oriented. Okay. Now the second difference. What is the second difference? The TCP sliding window is variable size. The TCP sliding window is variable size. Okay. But the data link layer sliding window is of fixed size. Okay. So these are the major differences between the sliding window in the data link layer and transport layer. For your remembrance, and for your remembrance, I'm going to just say it once again. The first difference is the sliding window in the TCP is byte oriented, whereas the sliding window in the data link layer is frame oriented. Okay. The second difference, the second difference is the TCP sliding window is of variable size, and in the data link layer, the sliding window is of fixed size. So these are the major, or these are the big differences, major differences between the sliding window in the data link layer and transport layer. Okay. Now, so let us now discuss about how this sliding window is exactly working in the TCP protocol. So how this sliding window works in the TCP protocol, let us see. So this is completely the sliding window in our TCP protocol. Okay. If you see here, this is our window spanning. Okay. So this is the first, the starting end, and this is the other. This is one end, and this is the other end. Okay. So this window is going to span a portion of the buffer which contains the bytes that are received from the process, isn't it? So if you take at the sender side, okay, the sender is going to give the information to application layer, and then the application is layer is going to give information to transport layer. Now in the transport layer we have TCP, right? Now we are going to maintain a concept of window. So in this window, what actually will be there? The window, let us say these are the two ends of the window. Okay. Now the window is going to span a portion of the buffer containing the bytes which are received from this particular process. Okay. So this information which is received from this particular process will be residing in this particular window. Okay. So the bytes which are inside this window I'm going to refer to. Okay. The bytes which are within or which are inside this window, okay, are the bytes which can be transmitted. That is, these bytes in the window, these bytes in this window can be transmitted. That is, they can be sent without taking into consideration about any acknowledgement. Okay. Next, the next point we have to discuss is that, if you see, this is our imaginary window, right? We are just assuming this imaginary window is having two walls. That is the left wall, this is the left wall, one on the left, and this is the right wall which is on the right. So we are having two walls in this imaginary window, and the window can be in any of the states. That is, the window can be open state. I'll just explain what is open state, closed state and all, but just I wanted to name them. So the window is open, or the window can be closed, or the window can shrink. That is, window can open, window can close, or the window can shrink. Okay. Now, so let us see what actually this means. Now, before discussing what are these, I just wanted to tell you one important point. These activities, that is opening, closing, and shrinking, all these three activities are in the control of the receiver. Do remember, the opening, closing, and shrinking activities are in the control of the receiver, and also they depend upon the congestion in the network. Okay, so this closing, opening, and shrinking are no way related to the sender, because we are discussing about the concept of flow control here. What is flow control? The receiver restricts the amount of information from the sender, isn't it? This is the sender and this is the receiver. Now the receiver don't want to get overwhelmed by the data which is sent by the sender if it is out of control of the receiver. So now the receiver is going to control, or the receiver is going to tell the sender, okay, sender, please send me the information as and when I require. So the information which the receiver requires, okay, this communication is governed. That is this window, that is the closing phase, opening phase, shrinking phase, all these are governed by the receiver only. The sender is not having any interference in these things. Okay. So here what actually happens, the sender has to obey whatever the receiver is telling, because the receiver is the one which has to receive the information, process the information, right? So the sender here has to obey whatever commands the receiver is giving. Okay, so let us now discuss about what are all these meant. Okay, the first thing, opening. So what is opening of window? Opening of window means moving this right wall. This is the right wall, right? Moving the right wall to the right side. Okay, moving the right wall to the right side is called opening. Okay, so what happens if we move this right wall to the right side? This allows more number of bytes in the buffer. That is, if it moves from this place to this place, more number of buffers are included. That is, let us say I'm going to clear this one. So, okay, if this is moved from here to here, then what actually happens? More number of bytes are now in the buffer. Okay, so all these bytes are now eligible for sending the information from sender to receiver. Okay, the next thing. The next thing is closing the window. What is the meaning of closing the window? Closing the window means moving the left wall to the right. If you see, closing the window means moving this left wall. This is our left wall, moving the left wall to the right side. Okay, if you observe this arrow mark, if you see here, this arrow mark is right side. Okay, so closing the window means moving the left wall to the right side. So this means what? This means some bytes have been acknowledged. That is, let us say, I'm just clearing again. Okay, now let us see if we move the left wall to the right side. That is, if this closing window wall is like this, that is what happens. All these values. Okay, closing this window means what? Means what? Some bytes have been acknowledgement. That is, these have been acknowledged. So as these have been acknowledged, now there is no need for these bytes to stay in the window. So for this reason, we close this window right side. Okay, so some bytes have been acknowledged, and now the sender need not worry about those informations anymore. Okay, so this is the second operation. The next one is shrinking. So if you see, the opening is from left to right and closing is also from left to right, but if you see, shrinking is from right to left direction. So shrinking the window means moving the right wall. This is our right wall, right? Moving the right wall to the left side. Okay, actually this is not recommended and it is not allowed in some implementations, because if we are trying to shrink this particular window from right side to left side, what actually happens? It revokes the eligibility of some bytes for sending. So what is the meaning of this one? See, actually, let us say initially our window is like this. Okay, now we opened our window from this place to this place, means now these bytes are eligible for sending. Now if we shrink again from this place to this place, again back to this place, what actually we are saying? We are now revoking the permission of these bytes to be sent by the sender. So for this reason, 99.9% the shrinking of the window is not allowed. Okay, now the next thing we have to discuss is, okay, so the size of the window at one end is determined by the taking the minimum value of two values. See, if you see, this is RWND, this is CWND. RWND means receiver window size, CWND means congestion window size. If you remember, in flow control, only two important entities play a major role, as I said, the receiver and the congestion in the network. So for this reason only, we are going to take into consideration about the receiver window and the congestion window. Okay, now what does the receiver window say? The receiver window is the value which is advertised by the opposite end in a segment which contains an acknowledgement. That is, if you see, this is the sender, this is the receiver. Now this receiver is going to advertise its maximum capacity of the buffer to the sender, so that sender can send only the bytes according to that particular receiver window size. Okay, next, then what about the congestion window? This one, congestion window. So this is the value which is determined by the network to avoid congestion. That is in order to avoid congestion situation. So what is congestion and all we'll be discussing in the next lectures. Okay, but for now just remember that this congestion window is advertised to say that the network can the network is capable of holding only this many number of bytes only. Okay, so these two are very important. Now what will be our final window size? What will be the final window size? Our final window size will be the minimum of the receiver window size and congestion window size. So this is what our actual window size refers to. Okay, so I hope up to now it is clear for all of you. నానా అర్థమైంది కదా అందరికి? Guys, you understood?
Yes, sir.
Okay, next. Now let us see some important problem. Now the question is, what is the value of receiver window RWND for host A if the receiver host B has a buffer size of 5000? Let us say we have host A and this is host B. Now the receiver is B, it is having a buffer size of 5000 bytes. Okay, and now it already received 1000 bytes. Okay, 1000 bytes have been received. Okay, and they are unprocessed. Now, what will be the value of receiver window? Obviously, what will be the value? If the receiver window has a buffer size of 5000, but it already received 1000 bytes. So, how many number of bytes it can again accommodate? 5000 minus 1000. So, the value of receiver window size will be 4000. That is, host B can receive only 4000 bytes of data before overflowing its buffer. That is, actual buffer size of the receiver is 5000, but it already received how many? 1000. So it can only receive more 4000 bytes. Okay, this is receiver window size. Next, what is the size of the window for host A, that is sender host A, if the value of receiver window size is 3000 bytes and the value of congestion window is 3500 bytes? Now what will be the sender window size? Now if the receiver window size is 3000 bytes and the congestion window size is 3500 bytes, what will be the value, final value? The minimum of receiver window size and congestion window size. So what is the minimum of 3000 and 3500? It is 3000 bytes. So finally the sender can send only the values up to 3000 bytes, because we should take the minimum of the receiver window and congestion window. Okay, next. So this is some actually a diagrammatic representation with some numbers. If you see, so these are all the bytes which are sent and they are acknowledged. Okay, so up to here, these are all the bytes which are sent by the sender and they are acknowledged by the receiver. Now these are all the bytes. Okay, so if you see, these are all the bytes which are in the window. Okay, and now if you see these bytes 200, 201 and 202, these are sent but they are not acknowledged. Okay, and then later as these are in the window, these can be sent immediately. That is, after 202 up to 208 we can send the bytes immediately. And if you see here from 2 after 208, that is from 209, we cannot send these bytes because the window has not expanded, window has not opened here, isn't it? So until and unless the window opens from left to right, we cannot send all these bytes. Okay, so now what will be the window size? The window size will be the minimum of receiver window and congestion window. So if the receiver window is 20 and if the congestion window is 9, what will be our final value? It will be 9 because it is a minimum value. Okay, next. So finally, about TCP sliding windows, we have some important points here. The size of the window will be now the minimum of receiver window and congestion window, and the source does not have to send a full window's worth of data. It can only send a data which is which is according to the receiver window. Okay, so it cannot send all the full worth of this window size, right? See here, only it is now it is allowed to send this one. Okay, and then it can send immediately this one. It cannot send all these values. Okay, next, the window can be opened or closed by the receiver only. Okay, and the window can be opened and closed by the receiver, but not by the sender. And the window should not be shrunking. Okay, now the destination, that is the receiver, can send an acknowledgement at any time. This point will be made clear when we have the next discussion, I mean in this session only. So the destination can send an acknowledgement at any time, as long it does not result in a shrinking window. Next, also the receiver can temporarily shut down the window, that is it can shut down its window, but the sender can send a segment of 1 byte even the window has been shut down. That is, if the receiver is going to shut down its receiver window, okay, even though it is shut downing its window, the receiver can always send a segment of how many bytes? 1 byte can be sent even though the receiver window has been shut down. So these are some important points about the TCP sliding window. Okay. Now, the next concept is error control. Okay, so after flow control, we are going to discuss about the error control concept. So we know that TCP is a reliable transport protocol. What is the meaning of this one? Reliable transport layer protocol. That is when application program which delivers a stream of data to TCP. That is, here we have an application program in the application layer. Now it delivers a stream of data to the transport layer, that is to the TCP protocol. In turn, it is going to transfer the data to the TCP protocol. So now the application layer delivers a stream of data to TCP, and now this application layer completely relies on this TCP protocol to deliver this information to the application program on the other side. Okay, so this is the sender side and this is the receiver side. So now this application program on the sender side completely relies on the TCP protocol, so that it can be reliably sent from the sender to receiver application program. Okay, that is, it has to send all the bytes in a particular order, and that is without error. It should not have any error, and the packet should not be lost, and the packet should not be duplicated. Okay, that is, the packets from sender to the receiver must go in a particular order only then the receiver can process, and it should not have any error, that is without error, and the packet should not be lost, and the packet should not be delayed. All these are the different properties which should be provided by the TCP protocol from the sender application layer to the receiver application layer program. Okay, so this is actually the meaning of reliable transport layer protocol. So for this, TCP is going to provide the reliability using error control. So what is error control? This error control mechanism includes detecting the corrupted segments. So in the transit, obviously when the segments are being transmitted, there will be lot of segments which are being corrupted. So in order to detect these corrupted segments, and in order to detect these lost segments, and in order to detect these out of order segments, okay, and in order to detect these duplicated segments, that is, again I'm going to again repeat, detecting the corrupted segments, lost segments, out of order segments, and then duplicated segments. So we have to detect and we have to correct all these different types of segments. Okay, so after detecting, the error control also includes a mechanism for correcting all these errors after the errors are detected. Okay, so now how error detection in correction in TCP is achieved? The error detection and correction in TCP is achieved using three simple tools. The first one is checksum, the second one is acknowledgement, and the third one is timeout. Okay, now what is checksum? Actually, we discussed this actually we discussed about this in the UDP protocol also. So each segment, let us say each segment we take. I'm just clearing the screen. 1 minute. Okay. So each segment we take. Let us say this is a segment. Each segment includes a checksum field also. Okay. Each segment includes a checksum field. Now, which helps for us to check for a corrupted segment. Okay, now if this segment has been corrupted, but is after checking the checksum, if the segment has been corrupted, now it is discarded by the destination TCP. Okay, here this is the destination, let us say buffer. Okay, so if it is coming here after checking the checksum, okay, if it is identified that it is corrupted, now the destination is going to discard this particular segment. Okay, and then it marks it as last segment. Okay, now it marks it as last segment. Okay, so TCP is going to use how many bit checksum? 16-bit checksum. So TCP uses a 16-bit checksum. which is compulsorily present in every segment. Okay, so after when if the checksum is calculated is correct by the receiver or by the destination, then it accepts the segment. But if the checksum calculated is not correct, then obviously it is considered as corrupt and it is completely discarded. It is not processed at all. Okay, so this is about checksum. Now the second one is acknowledgement. So coming to the acknowledgement, TCP protocol is going to use acknowledgement concept to confirm the receipt of data segments. Okay, so whenever the sender is sending the information to the receiver sends an acknowledgement to the sender. So after it gets the acknowledgement from the receiver, now the TCP confirms that the data packets or the data segments have been received correctly by the receiver. Okay, now there are some control segments also which will be moved from source to sender to receiver or receiver to sender. Okay, so these control segments are not having any data. Okay, they are having only control information. That is, they consume a sequence number. Okay, these control segments, they have a sequence number. Okay, and these control segments are also acknowledged. Okay, but segments are not acknowledged. That is, let us say this is sender and this is receiver is sending an acknowledgement. Okay, now for this acknowledgement, again the sender will not send any acknowledgement. Okay, so acknowledgements are never acknowledged, but the control segments are acknowledged. Okay, so one important thing to remember is the acknowledgements which are being sent from sender to receiver and receiver to sender. These acknowledgement segments do not consume any sequence number. Okay, and these acknowledgements are also not acknowledged either by sender or receiver. Okay, the next thing is about timeout. So timeout means we are going to do retransmission. Okay, so actually the main important thing in the error control is the retransmission of these segments. Actually, we can write it as retransmission. Retransmission. Okay, so the retransmission is actually the main important concept when we are discussing or when we are dealing about the error control. So when a particular segment is corrupted, so when a particular segment is corrupted, let us say this is a segment. Okay, so whenever a particular segment is corrupted, or it could be lost, or it could be delayed. That is, a segment can be corrupted, or it could be lost, or it could be correct, or it could be delayed. In case of these three issues, now a segment will be retransmitted. Okay, so generally segment is retransmitted in two occasions. The first occasion is when the retransmission timer expires. Okay, when the retransmission timer expires. And the second one is when the sender receives three duplicates. Okay, so this case and this case will be seeing shortly. Okay, now the important point which we have to remember is the retransmission actually happens in two important cases. When the retransmission timer, okay, it is the retransmission timer, if it expires, then we have to resend the segment. And if the sender is continuously receiving three acknowledgements that are duplicate, that is, the sender is receiving three acknowledgements for the same segment. That is, if it receives the duplicate acknowledgements, then retransmission also happens. Okay, so these are all the different types of things which we use for error detection and correction in TCP. Okay, so now we are going to discuss about the different types of operations, different types of scenarios while we are sending the information from sender TCP to receiver TCP. So first we'll consider about the normal operation. The second we'll consider operation when the segment has been lost between sender and receiver, and then we discuss about what is fast retransmission. Okay, so let us now first look after the normal operation. Now coming to the normal operation. So if you see here the data transfer is bidirectional. That is, information is from client to server and also from server to client. Okay, so remember this point here. The information is bidirectional. Now, if you see in this figure, the client is going to send one segment. If you see, the client TCP is going to send one segment here. Okay, so this segment is sent with the sequence number 12012 1400. and it is sending acknowledgement 4001. What is the meaning of acknowledgement 4001? Means the client has already received all the segments up to 4000 successfully. Okay, now it is expecting the next segment with the sequence number 4001. Okay, so this is the meaning of this one. And now here, this one, the first part, the client is sending the segments with the sequence number 12,000, 1201 to 1400. Now this information will be sent to the server. Now after receiving this information, what the server is doing, if you see, these are in the yellow color. Now the server is sending the data bytes from sequence number 4001 to 5000. If you see here, it is sending the acknowledgement 4001. So up to 4000 it has received the information successfully from the server. Now for this reason, server is now sending the information from 4001 to 5000. Now the server is sending the acknowledgement 1401. What is the meaning of 1401? From the server up to 1400, the server has successfully received all the bytes without all the segments without any problem. Okay, now it is expecting 14,000 1401th segment. From 14,001th segment it is expecting. So now this information will be given to the client. So if you see here, when when the client is getting the information from the server, okay, here a retransmission timer has been set up. If you see, so here it has decided 500 milliseconds as the retransmission timer. Now, so if you see, after some time only the client is sending the acknowledgement. Why means, if you observe here, client is sending only one time. Okay, so the server is sending three times. Okay, the data transfer is done three times. So because the client do not have any more information to send, okay, so it don't want to send the acknowledgement all the time. For this is the reason it is going to wait for some amount of time, that is 500 milliseconds. That is, it thinks that if server sends me some more information, I can send the cumulative acknowledgement at a time. But here the transmission timer, that is the acknowledgement timer, has expired at this moment of time. Now it is sending this particular information, that is it received this information from server to client. Now it waited some amount of time. In this span of time it did not get any information, so as the timer expired, now it is sending the acknowledgement for 5001. What is the meaning of 5001? It got all the information up to 5000 segments. Okay, now it is expecting 5001th segment. Okay, so this acknowledgement reached to server. Now the server, it is sending information from 5001 to 6000 and with acknowledgement 1401. So what does this mean? That is, the server received up to 1400. Now it is expecting 1401 segment. Okay, but the client do not have any information, right? Okay, so if you see, less than 5000 millisecond, the server has sent some more information here. Okay, so before this timer expires, the server has sent the second data transfer in this time limit. Okay, so actually the client has to send the acknowledgement for 6001, but it has sent acknowledgement for 7001 because within this particular timer it got the second information also from the server. So it has sent the cumulative acknowledgement for 7001. That is, it received, the client received from 6001 to 7000. So it sent the acknowledgement for 7001th segment. Okay, so this is how actually the normal operation is taking place. Okay, so I hope this is clear, right? Now coming to the next thing about the last segment. So coming to the last segment, if you see now again, so here we are dealing with only the information sent from sender to receiver. Okay, we assume that the receiver is not sending any information to the sender. Okay, only unidirectional communication from sender to receiver. That's it. It's just an assumption to tell how last segment kind of scenario is going to work out. Okay, so now initially sender is sending the segments with the sequence number 501 to 600. Okay, so it is sending acknowledgement to X. Why we mentioned this as X means we are not concerned with the sender sending the acknowledgement for the receiver. Okay, we are only dealing about this thing here in our discussion. Okay, so now information from 501 to 600 received by the receiver. Okay, and again in the second time, okay, again it is sending 601 to 700. Okay, now if you see the receiver buffer, initially the first part of the receiver buffer has been filled here. Now for the second time, the second part is also filled. First part and second part is filled. Now the receiver has sent the cumulative acknowledgement. If you see, ACK 701, that is it received up to 700. Now it is expecting from 701, so it is received by the sender. Now, if you see here, now the sender is again sending the information from 701 to 800. So if you see, this is a retransmission timer, that is retransmission timeout. Okay, so this is our timer, that is from this time to this time. Okay, so if you clearly observe, for the third time, it is sending the segments from the sequence number 701 to 800, but this information has been lost. Okay, and it is also sending sequence number 801 to 900. Okay, now it is sent to the receiver. If you observe here, now what is the receiver receiving? Now what is the receiver sending the acknowledgement? It is still sending the acknowledgement for 701th segment only. Why? Because this has been actually lost. That is sequence number from 801 to 900 it received, and it is filled that one in here. Okay, but it is out of order because it is expecting the third part, but it got the fourth part. So this is out of order out of order segments. It got the out of order segment. So now for this reason it is going to send acknowledgement for 701 only. See, like this only. So because it did not get the 701 to 800, until and unless it gets 701 to 800, it will always send the acknowledgement for 701. Now when it sends the acknowledgement for 701, now within the timer, okay, within the timer only it got the acknowledgement. Now what it is going to do, it got the acknowledgement as for 701. The sender is again going to resend the information, that is from 701 to 800. The sender thinks that the receiver did not get this information because of some corrupted or lost information is done in the network. It is again resending the information. So when it resends the information, now it fills this gap. Okay, and then it is going to fill this information here. Now everything is in order. Okay, now see, if you see here, now it sent the acknowledgement for 901. So because for 701 to 800 it filled here, and 801 to 900 it filled here. Okay, now it is expecting from 901, so it sends the acknowledgement for 901. So this is how the TCP works if the segment has been lost. That is the out of order packets, that the receiver will not process any out of order packets. The receiver TCP will only process all the packets or all the segments only when the segments are received in a order only. Okay, next, coming to the next one, fast retransmission. So if you see here, the sender has sent the information for from 101 to 200, the receiver buffer is filled like this, and from 201 to 300 it is filled like this. Okay, now it has sent the cumulative acknowledgement. Receiver sent the cumulative acknowledgement 301, that is it received up to 300. Now it is expecting 301. So now the sender has sent 301 to 400, but this is also lost in between. Okay, now if you see here, whenever this information is lost by the whenever this information sent by the sender is lost in the network. Okay, so it is now sending the next transmission. And if you see, whenever it is received by the receiver is still sending the acknowledgement for 301. So this 401 to 500 is actually taken by the receiver, but it is not processed. Remember, it is taken and it is kept in its appropriate place, but it is not processed. Okay, because selective repeat, we discussed about the sliding window of TCP selective repeat. Okay, until and unless it gets all these things, it will not be processed. Okay, so now for the first time, the acknowledgement 301 is sent. Okay, now so in this meantime it is sending 501 to 600. When it again send 501 to 600, it is placed here, but again acknowledgement is sent for 301 only. And now it again sent 601 to 700. It is placed here, and again acknowledgement is sent for 301 only. Okay, so whenever it gets the acknowledgement for three consecutive duplicate acknowledgements, see, these are all the duplicate acknowledgements. Whenever it gets the three duplicate acknowledgements consecutively, then obviously it will retransmit. Okay, this particular segment for which it is getting the uh, uh, acknowledgement duplicate. So whenever it get three duplicate acknowledgements, it will again send this information. Now the information is placed appropriately here, and now it got all in order. Okay, and then it is now sending the acknowledgement for 701. So until and unless it get all in order, it is sending the same acknowledgement for 301 only. Okay, so this is how fast retransmission actually happens. Okay, so is this clear? Is this clear? So actually here RTO value, that is retransmission timeout value, is somewhat more, okay, because it spanned up to here. Okay, for this reason it has sent all this information actually. Okay, this is about fast retransmission.